All right, this one we better know. Yeah, if we're getting ready for certification in this area, we better know this one. How does nhost virtualization mode maintain a loop-free topology? How does nhost virtualization mode maintain a loop-free topology? Do you remember this? Is it spanning tree protocol? Is it rapid spanning tree protocol? Is it multiple spanning tree protocol? Is it per VLAN rapid spanning tree? Or is it MAC pinning? Well, if you had to guess this, because maybe you just didn't have any clue, it'd be pretty easy to guess this one, wouldn't it? Does one of these things seem unlike the others? Yeah, sure. MAC pinning sure seems unlike the others. The others are all valid flavors, styles of spanning tree protocol, but we know when the fabric interconnect is operating in that EHV, that nhost virtualization mode that we know it's going to default to, it's going to engage in MAC pinning. This eliminates us from having to worry about any misconfigurations or any delays that are caused by spanning tree protocol. So pretty cool, MAC pinning. Which two statements are true about static uplink pinning? So that was MAC pinning. Now we convert over to discuss static uplink pinning. You can select one interface uplink on each fabric. You can select two uplinks on each fabric. You can select two port channels on each fabric. You can select one uplink and one port channel on both fabrics, or you can select one port channel on each fabric. You know, if you recall, when we statically pinned our uplinks, we would do one interface for the pinning on each fabric interconnect. And by the way, you could do one port channel on each of the fabrics if you were dealing with port channels. Very good. So we saw an example in class, right, where we said this particular Red Hat server VM, we're going to statically uplink pin it to one port over here and one port over here on the two fabric interconnects. Great job. Which statement is true about static uplink pinning? You can select one interface uplink on each fabric. You can select two on each, two port channels. Hey, this is easy. This is like the question we just had, right? We're going to select one interface uplink on each fabric when we are doing the static uplink pinning. Simple. Okay, now this is a good one. This is an interesting one. Ready for this? Which two statements are true about automatic uplink pinning? Okay, automatic uplink pinning. If a fiber channel uplink goes down, the server automatically gets pinned to the next available uplink on a new virtual storage area network. Okay, if the fiber channel uplink goes down, the server automatically gets pinned to the next available uplink on the same vSAN. C, a multipath I/O driver is required for automatic repinning, or a multipath I/O driver is required for high availability. We talked about this. If the fiber channel uplink goes down, the server will get repinned to the next available uplink on the same virtual storage area network. Great job, Pete. And D, there better be software that is on that particular server that can know to cut over. So we need a multipath I/O driver, and that's going to be a requirement for the high availability. Awesome work. So yeah, remember, the fabric interconnects, we're going to cluster them together for the redundancy and the high availability, but there are still going to be requirements as far as the configurations in our VMs to make sure that they can fail over properly to the other device. Which statement is true about uplink pinning? 512 vSANs per uplink, 256 vSANs per uplink, 1 vSAN per uplink, 512 vSANs per fiber port channel, 256 or 1. Do you remember the one rule that was true? And I need you to memorize this. That's why this slide is here today. Great job, everybody. Awesome work. We can configure 1 vSAN per uplink. Great stuff. Absolutely have to have that memorized for certification purposes. Now this one's a little bit tougher than it would be in the exam, but see how you do with this one. Which 3 are true fiber channel port combinations? Which of these are true, correct fiber channel port combinations that we can have? Do you remember? We actually showed you these. All right, the N port to F port, good. An E port to an E port, and an NP port to an F port. The NP port is that Cisco N port virtualization feature, that really cool feature that Cisco can do. And so that's why we have the NP port to F port. Good job. The exam would not be this difficult. Yeah, the exam would not be as difficult as what we just saw there. Okay. Well, I said today would be really simple and straightforward. And guess what, folks? It will be. Let's jump into the new content for today. It's Chapter 6. You're going to love it. What we want to do here in Chapter 6 is we want to make sure that we provision the server resources in such a way so that, number one, they're easy for us to roll out, and they roll out in a way that is highly available. In other words, if you've got a server, like an Oracle server, and it's running on one of the blades in the chassis, and that blade has some type of a malfunction, you want to be able to take that blade out, stick in your new blade, and get the server running just like it was before with just a couple clicks of the mouse. As a matter of fact, with VMware's solution, you might want to take advantage of vMotion, and you may want to move that VM from one blade to another blade with a couple of mouse clicks. Obviously, in order to get this level of independence, we have to play some tricks with resources. We've already alluded to that in this course, haven't we? We've already talked about things like MAC addresses and worldwide names and universally unique identifiers for your server blades. Yeah, we need a way in which we can virtualize all these important identifiers so that we can abstract these particular servers. Now, what we're going to do today is we're going to see how we can build a service profile for particular servers so that they get everything they need. Yeah, everything they need can be accommodated out of what we call a service profile. This is one of the great aspects of the unified computing system. Now, before we go and create the profile itself, what we're going to do in here is we're going to see how you can create pools of resources. We might know in the storage area networking, we need the worldwide names. We know for the blades themselves, we need essentially a serial number, a universally unique identifier for the blade itself. And then let me get out of the way here. We obviously need MAC addresses. So what we're going to do is we're going to go ahead and create pools of these resources, and then we can tie these pools into a service profile so that that information is available for the unified computing environment. So, logical resource pools are the entities that we are going to use. And like I said, we'll put these logical resource pools into service profiles in order to facilitate what we call stateless computing. Remember, stateless computing is that whole sense of being able to, move a virtual machine from one device to another device, and no one will know. Your end users will not know when there is that migration of the operating system. These are obviously truly remarkable capabilities that we have available in today's data centers, thanks to companies like Cisco and VMware. And again, I don't mean to slight Citrix or Microsoft either. Obviously, they have really great products that allow this level of virtualization and automatic moving of VMs. Okay. So, resource pools, physical resource pools, by the way, are available to us. We use these to create groupings of particular blade servers. And I'll show you how you can build a physical resource pool of your blade servers that gets populated automatically based on particular criteria. But the first pool, the first resource pool that we are going to discuss you creating is that universally unique identifier. These are global identifiers for your compute nodes, for your blades. And this is typically a 128-bit identifier code that's coded into the BIOS. And by the way, that is something that I want you to memorize. We are dealing with 128-bit numbers here. Okay, so this is normally burned into the machine's BIOS. Well, we need to go ahead and generate these, right? Because we don't want this code to change each time the underlying server hardware changes, right? We want to generate these and allow them to stay with a particular service profile, for instance, so we can move machines between blades and not have any problems. Notice Cisco says, all right, look, in UCS Manager, we'll go ahead and allow you to do a 64-bit prefix in order to create these universally unique identifiers. And it is recommended that these be set to the same 24-bit organizational unit portion that you would have in your worldwide names. So use that consistent 24-bit OUI and pad as necessary for a particular numbering scheme in your organization. So again, globally unique 128-bit numbers, a configurable 64-bit prefix, and we'll typically utilize the same 24-bit OUI as we have in our worldwide name pools. Okay, so how do we do this? Well, we go in, notice where we are. We go into the UCS Manager and we go to the Servers tab. Then there on the Servers tab, we expand the Pools area. And then notice under the Pools, we have UUID suffix pools when we right click, and of course we have the ability to create one. So I'll go ahead and select create, and this will bring us to a wizard that walks us through creating this particular universally unique ID pool. So we go ahead and provide a name, and we provide a description. By the way, the current maximum number of compute nodes that you could have in the UCS system is 320. Okay, so that's just something to keep in mind. Obviously, we can create 320 of these, and that's going to max us out on the UCS system anyways. By the way, notice this option. If we select derived, which is the default, the UCS manager is going to go ahead and supply the prefix for us. If we choose other, then we'll have to go ahead and supply the first 16 bits of the universally unique identifier. But derived will allow UCS to automate that for us. So here you can see our next step. Our next step, after we've provided the name and the description, is to actually add the universally unique ID blocks. Remember, it's a best practice here to only pre-allocate the number of identities in a given pool that is going to be actually utilized in your environment. You need to do kind of a near-term forecast, right? Here they input that they want 320 of these things, and that's kind of interesting. Like I said, that's the max for this version of the UCS. All right, so here we have our 320 UUIDs that were created. They were created using a derived prefix. So UCS provided the prefix for us, and then it went in and did all of the 320 suffixes to ensure uniqueness. And now that this has been created, these addresses would be available for a service profile, and we'll show you that. And Pete says, yeah, in the 320 max, that's for like our current UCS system. That number is going to go up in later technologies, and that's exactly right. So be aware of that. Sure, be aware of that. As you move to the 2.x equipment, be aware that the scalability is going to increase, so you need to be aware of that for your resource pools that you're creating. Okay, well that was easy. I'm guessing that Mac pools are going to be just as easy. Yeah, they are. We are going to go into the organization where the pool will be created and choose Create Mac Pool. Notice we're under Pools once again. And by the way, notice that these organizations have been created in here, right? So here's Hypothetical Inc. Here's a sub-organization. Here's an organization called the Americas. We covered these in the design class, but suffice it to say that when we go in and create these organizational identifiers, it's just a way in which to keep our resources organized more appropriately. All right, so we go in and we click Create a Mac Pool. And once again, we give it a name, we give it a description, and then we go ahead and have the UCS system create the MAC addresses for our server resources. Notice here Cisco provides a 3-byte OUI assigned to it by the IEEE. We don't really recommend that you modify this. Just go ahead and go with the prefix that Cisco suggests. The last thing for you to do here is just verify your Mac pool is correct, and then choose Finish to create this wizard and see that you have a new Mac block pool that is available for assignment. Again, what are we going to do with these things? Let's remind ourselves that we're creating these resource pools because they're going to be used by service profiles. Yeah, our service profile is how we can roll out the server with everything that it needs, and they'll be taking those, they'll be consuming these resources dynamically out of the pools. How about worldwide names? We know that worldwide names are 64-bit addresses that have many possible formats. And the Cisco UCS manager enforces a specific format for all of the worldwide name pools. There are certain ranges that have to be used in the Cisco UCS. So Cisco recommends a particular worldwide name prefix that you should use, and there it is on screen for you. You do not need to memorize this. I'll just highlight it though. This is what Cisco recommends that we use as a prefix for worldwide names. Again, no need to memorize that. You can just look that up in the course should you need it. Again, we want to make sure these things are unique. There's worldwide network names, there's worldwide port names, and you'll want those to be distinguishable between each other. And you may want to consider going in and using some kind of a numbering scheme in the suffix portion that can identify particular things for you. You know what I mean? You may want to go ahead and inject some intelligence here into the numbering. For example, maybe worldwide names that feature 01 are for a certain building, and then 02 are for a different building. So don't be afraid to encode meaning into these worldwide names as much as could benefit you. Once again, to create this particular resource pool, pretty easy. This time, notice though, we're going over to the Storage Area Networking tab. Yeah, that makes sense. We'll go down to the particular sub-organization that we're interested in, and we will create the worldwide name pool using the appropriate option. Here you can see a wizard will walk us through this. Again, a name and a description, and then the worldwide name block screen where we'll put in the prefix and then what other additional numbering that we want in the prefix, and then we will indicate how many of these that we want created in the particular pool. The last thing for us to do is to confirm the configuration and save it, and then make sure it is created for us and does appear on the storage area networking area in the appropriate organizational area in our hierarchy. There's the worldwide port name, and obviously there is a pool resource for that. So we can navigate to the correct area on the SAN tab, and we can create the worldwide port name pool by selecting that appropriate button. Remember, this worldwide port name, we're going to need one of these for every virtual host bus adapter we have in the Cisco UCS. Yep, so let's make sure we have enough of these for our virtual host bus adapters that we have out there in our infrastructure. So we just verify that this wizard worked beautifully, and then we go ahead and click finish, and then we verify that the appropriate pool was added in the appropriate organization inside the UCS manager. All right. Now, what about pools of actual compute resources? Well, yeah, we can have those in UCS, of course. And server pools are really pretty neat because you can create these pools of compute resources manually, or you can define rules for the automatic population. Yeah, pretty cool. So you can go in and you can manually say, okay, I want this pool called QA, and you can manually drag the particular server resources that you want in that pool. Or you can define rules so that the server pool will be automatically populated based on particular parameters of the hardware. Also notice what this shows us here. Clearly, we see that a particular compute resource can belong to more than one server pool at the same time. And this is between chassis. Yeah, great question, Pete. So if we have multiple chassis that this UCS is managing, yes, it could involve compute resources across all of our chassis. Very good. Something else to keep in mind, the UCS manager is currently getting an overhaul from Cisco, and the latest, greatest UCS manager that's coming will allow for the management in the GUI of multiple data centers. Yeah, so let's say you have a big UCS install in North America, and then you've got a big UCS install in another data center over in London. Finally, the UCS manager is going to allow the multiple data center management as opposed to what it does now, and that is just your one grouping of chassis that can constitute a local data center. So real soon, UCS Manager will be able to manage across different data centers. All right, well, let's go ahead and take a look at this wizard. First, we got to find it. We are going to an appropriate place. We're going to the Servers tab. And on the Servers tab, notice there is a Pools option. And we can right-click Server Pools and choose Create Server Pool in order to launch the wizard. You're going to give this server pool a name and a description. And then you can go ahead, as we alluded to, and manually populate this particular server pool by selecting the particular compute resources that you want in the pool. The double-headed arrow is the way in which you will select the particular devices to be in your pool. Then all you would have to do is say, finish, I'm happy with the results, and that server pool will be created and will be populated with the appropriate compute resources that you added to it. But wait a minute. What about creating one of these pools that will automatically populate based on settings that we give? Well, no problem. What you do is you create an empty server pool, okay? And I need you to memorize these steps, as you might guess. So we create an empty server pool, and then we create the server pool qualifications, like how much CPU, how much RAM is in the device, etc. Then we create a server pool policy. All this is doing is associating the qualification policy to the empty pool that we created. And now, auto placement of compute nodes will happen in this pool. This will happen at discovery. And by the way, if we re-acknowledge the chassis, that would also cause devices to hit the particular pool. So, one of the things to consider is if you've got a whole bunch of existing compute resources out there, go ahead and re-acknowledge the chassis after you do this in order for the server pool to properly, automatically populate. Makes sense, right? We do this, and then this is a great time to go ahead and do a re-acknowledgement of our UCS equipment. All right, so let's take a look at this. Here we go in and we create a new server pool. Okay, so we create a new server pool and we leave it empty. Yeah, this server pool is empty. And Sean asks, is a re-acknowledgement disruptive? No, Sean, a re-acknowledgement should not be disruptive. Yeah, so the good news is re-acknowledgement should not be disruptive to operations. There are some things that we'll see today, like deploying servers and stuff under certain conditions that can be disruptive. But yeah, re-acknowledgement should not be disruptive. All right, so here is our empty server pool. And now what we're going to do is we're going to go in and create that new qualification policy. So notice where we are. We're under servers. We're under policies this time. And here we have a server pool policy qualifications area. And we can right click and create a server pool policy qualification. As you might guess, we are stepped through a wizard that allows us to do chassis and server qualifications, memory qualifications, CPU and core qualifications, storage, server model, all kinds of great criteria in which to auto-populate this particular server pool. So we go in and we make the appropriate selections to build criteria for the auto-population in this pool. Okay, now our next step is to tie these two things together. We do this with a server pool policy. Again, we're on the servers tab. We go under policies and we choose server pool policy and we right click and create new. We give it a name and a description and we just take the pool we created that's empty and we tie it to a particular qualification policy. It's that easy. So we create this thing and then sure enough, after we create it, two servers are automatically added. Now notice servers that have already been discovered won't be automatically matched, so we would have to do a re-acknowledgement in order to get these servers to dynamically populate in the appropriate pool. Obviously, if you take a new blade and you introduce a new blade into the UCS system, well, it's going to be discovered at that point, and upon discovery, it will go into the correct server pool. So no problem for adding new stuff. It gets discovered and placed in the appropriate pool automatically. Now, before we take our break, there is something that we really need to emphasize to you here. And what we need to emphasize is the fact that be very careful when you're creating these objects in your organization. By organization, I mean that logical structure that you can create in the UCS. Be very, very careful about this because you can't move these objects around. You cannot move them. Yeah, there's this really interesting thing, like here we're selecting a server pool and we're right-clicking it and you notice there's a copy option. So administrators immediately go, oh, all right, cool. I created that in the wrong place, no problem. I'll just copy it and paste it into another part of the organization. That does not work. That doesn't work because there's no paste option. You cannot move these objects once you create them. You can delete them and then go to the correct location in your organization that you've built, but obviously that's a lot of work. So please be very aware and really think out your organizational structure and what needs to go where, because there is no easy movement of these particular objects. Alrighty, well, when we return, we will see how we can utilize these resource pools that we created and how we can tie them into a service policy. And you'll see the remarkable capabilities that we'll get for implementing new compute resources thanks to these service policies in the UCS system from Cisco.